Newton's second law, the law of acceleration. Newton's second law, or the law of acceleration, states the acceleration of an object depends on the amount of force applied to the object and to the object's mass. What? Alright, well, that's a lot of words to mean something that's not so hard. Okay, so stay with me here. Alright, this triangle is a force-mass acceleration triangle. Okay, I don't know if you've seen this before or not, but I'm going to try and walk you through here on how to use this. This triangle can help us figure out what this means. Okay, so let's walk through this. Acceleration A of an object is equal to the amount of force, I'm going to call that F, divided by the object's mass. Okay, so the way that this triangle is going to help us is just like this. We're looking for A. Okay, and what that leaves us is force over mass. Force over mass. Okay, so whichever letter you're solving for, we're going to put a box around it. Okay, so we're solving for A. We're trying to figure out what A is, the acceleration, and that leaves us force over mass. Okay, so let's go ahead and clean up here. Okay, now let's say that we were given the mass of an object this time. Well, what's left over here? Now we have force over acceleration. So that would be force over acceleration equals the mass. Okay? And we'll do the last little formula here, because this triangle gives us three formulas. If we're looking for the force, okay, we know how fast the object's accelerating. We know how much the mass is. Okay? In math, if you say A is by m, A by m, you're multiplying. So that would be acceleration times mass. Or, typically, the way you'll see this is mass times acceleration. Okay? And this is how it's going to appear on your star chart, on your formula chart that you get during the STAR test. Okay? It'll show up as force equals mass times acceleration. So, continue on here. This is exactly what we just came by. Okay? Acceleration. You have your acceleration here. And what's left? Well, the thing that's left is your force over your mass. Okay? If you're looking for the mass, okay, what's left is your force over acceleration. And then finally, if you're looking for your force, you have your mass by your acceleration, or your mass times your acceleration. Alright, so we know how to measure it, or at least we can figure out how to measure it. How can you tell or identify the second law of motion? Well, Newton's second law takes three forms. The first one is speeding up, then there's slowing down, and then finally the last one is changing direction. Okay? Here is an example of objects speeding up. So this is acceleration. Definitely a change in motion. Okay? Definitely a change in motion there. Here's an example of slowing down. We call this in science negative acceleration. Oftentimes you'll hear deceleration, but in science there's no such thing. It is simply acceleration in the opposite direction. And that video is showing the difference, or actually it's really a research done by a brake company showing the advantages of their brake product versus a standard product. And they're showing that their product helps stop a semi-truck a lot shorter than this other truck. And finally, here's an example. This example actually has several types of acceleration in here. We have speeding up, and we have change in direction, as well as a little bit of negative acceleration there due to gravity. And we have changing direction again. And finally, we have examples where there is zero acceleration involved. Okay? The first one is when you have an object that is not moving or without motion. Okay? So if you have a book sitting on your desk, just sitting there, has zero acceleration. And then finally, if you have something that's moving at constant velocity, okay, in the same direction, at the same speed, okay, for example, the Voyager 1 and 2 deep space probes, okay, that are reaching the end of our solar system, they're traveling at 17 kilometers every second. Every second, they're going 17 kilometers. That is about 10.5 miles every second. And there you have it. That is Newton's second law.